Hey Math 8, this is Mr. Bainey, and we're going to take a look at, hey, what's up Math 1? We're going to take, hello, this is Mr. Bainey. Let's take a look at lesson 19.1. This is angles formed by intersecting lines. So we're going to look at the relationships between angles when we have the two lines intersect. So I'm going to go straight to our next page. This is a good explore activity here on the front page if you're going to use a protractor to measure angles, because it's going to help you understand the measures of the angles and how they relate to each other before we actually get to our vocabulary. On the second page, our first angle relationship we come across are vertical angles, and the linear pairs also are mentioned here because linear pairs showed up in, I believe it's module 16, and we define a linear pair, and also there's a linear pair postulate. Remember that linear pairs are supplementary, so they add up to 180 degrees. Okay, just below that is the vertical angles theorem, right? I want to direct your attention back up here again to the top, because this up here is the definition of vertical angles. The definition just states what it looks like. The vertical angles theorem just tells you that they're congruent. Okay, so if we have the two intersecting lines, we have four angles in here that are created by the intersecting lines. It says that if they're vertical angles, so angle 1 and angle 3 are vertical, angle 2 and angle 4 are vertical, right? It's pretty much if they don't make a linear pair, they're going to be vertical. They're just across from each other. So they're congruent. If I told you that angle 1 is 100 degrees, down here angle 3 has to be 100 degrees. Okay, just below that, they put this kind of in a weird place, but there's a definition for a flow proof from the last lesson, right? It's in the last unit. We did a two-column proof, and we're normally going to just stick with that type of proof. So a flow proof is our second type of proof that we could write, but unless you are very confident in writing proofs, coming up with the statements and the reasons, flow proofs can be very, very difficult. Okay, but they're going to show you what a flow proof looks like by proving this vertical angles theorem. Here on page 935 is the flow proof, but there are some fill in the blanks here that they want you to do. I'm not going to worry about filling this in just because, again, I want to get us comfortable with writing two-column proofs and trying to structure it that way. Okay, let's go ahead and apply this vertical angles theorem. Let's see how this works. So number 6 states that the measures of two vertical angles are 58 degrees and 3x plus 4 degrees. Find the value of x. Well, the vertical angles theorem, remember, it states that the two vertical angles, they're going to be equal measures, or they're congruent, which means that 58 degrees is going to be equal to the measure of the other angle. So the 3x plus 4 has to be 58. We just go through and we solve this. So subtract 4 on both sides. I get 54 equals 3x, and divide both sides by 3, so x will be, what is that, 18, and we're done. Okay, go ahead and pause this video, and I want you to try number 7. Looks like it's involving vertical angles again, so you're going to set it up just about the same way. So go ahead and pause it, and I will go through the solution. All right. The first angle that's given is x plus 3. That's the measure of one of the vertical angles. The second vertical angle is 2x minus 7. So we know those two are equal to each other. So we just solve this. So subtract x on both sides. And I get 3 equals x minus 7. Then I add 7 to both sides. So x equals 10. The question here does not say find the value of x. Remember, number 6 told us to do that. Number 7 says what's the measure of each angle. If x equals 10, then x plus 3 is going to be 13. That's 13 degrees. So we're hoping that this is going to be 13 degrees. Remember, they're both equal, right? But if we just worked it out, 2 times 10, right, x is 10, minus 7, that is going to be 13 degrees. Supplementary and complementary angles are defined here. It's weird that they define the supplementary here because they used the term supplementary back when you first saw linear pairs. But it's a good reminder that supplementary angles add up to 180, complementary adds up to 90. And complementary means that pretty much they make up a right angle. So let's go to our your turn. We are on page 938. So here we have the measure of an angle and its complement, right? Complement means that, here I'll put an example up at the top for you. If we have two complementary angles, so let's say here's a right angle, then if I tell you that this angle inside is 20 degrees, then this one would have to be 70 degrees. So let me zoom in, sorry. That means that 20, the complement to 20 is 70, and the complement to 70 is 20. On the other hand, if I were to just tell you that one of the angles is x degrees, then in order to find its complement, we just take x and subtract it from 90. So that means the other angle is just 90 minus x and degrees. Because x plus the other angle, which is 90 minus x, right? That's going to equal 90 degrees because x and minus x goes away. Okay, so that's going to help us in solving some of these problems algebraically. Supplementary angles obviously will work the same way. You just replace 90 with 180, and it's the same thing. Okay, so let's look at our your turn after I erase all this stuff here. Number 9. So we have the measure of an angle is equal to the measure of its complement, okay? So the measure of an angle, we don't know what the measure of the angle is, so let's use x or whatever variable you want, is equal to the measure of its complement. Well, the complement to x would be 90 minus x. So our equation is x is equal to its complement, like that. So if x is equal to 90 minus x, let's figure out what x is. I need to add x to both sides. So adding x on the left gives us 2x. That equals 90. And then we divide both sides by 2, and we get 45. So we need to find the measures of both angles. Let me underline the, I didn't quite read the whole instructions there. Find the measures of the angles described. So they describe the measure of the angle and the measure of its complement. So they're both 45 degrees because the angle, the first angle is going to be equal to its complement, which is the that second angle, the 45 degrees, both equal. Okay, number 10 is slightly more challenging because it includes the twice the measure of. But go ahead and try it out. I want you to pause it. Try this before you see my solution. All right, let's work out number 10. The measure of an angle, we can label that as x, means equals, twice is 2 times the measure of its supplement, and that is 180 minus x. Our equation is x equals 2 times that whole supplement measure, 180 minus x. We need to distribute the 2, and we get x equals 360 minus 2x. I'm going to add 2x to both sides. We get 3x equals 360. And finally divide by 3 to get x equals 120. Okay, 120 is the measure of the angle. That's one of our solutions. If I reread the problem, that measure is twice the measure of its supplement. So it's going to be twice the measure of the other angle that it's supplementary to. If you want to, you can just subtract 180 minus 120, and you'll get its supplement. Or if you divide it by 2, right, you'll get 60. You'll get the same exact solution. Okay, so 120 is twice of the other angle, 60. And that's it. So we're done with this lesson. Thanks for watching. Have a great day.